Hey guys, it's Danny here from Disrupt Tutoring, and as always, it is a pleasure to join you. Today we're going to be doing a chemistry multiple choice question from the November 2019 grade 12 physical sciences paper 2. The question asks, which of the following covalent bonds is the most polar? So to answer this question, you will need to recall the definition of polar covalent bonds as well as the definition of electronegativity. Covalent bonds form between nonmetals, and covalently bonded atoms share their electrons between them. Polar covalent bonds form when the electrons are unequally shared between the atoms, and there is therefore an uneven distribution of charge in the molecule. Now, different elements attract electrons to different extents. So that means that for the four options given here, one of the elements in those various polar bonds will attract the electrons a lot more strongly than its counterpart, making it the most polar bond. The quantity that indicates this extent of attraction is the electronegativity of the element. So if we have a look at our periodic table, you will actually see that the electronegativity is printed on the top right-hand corner of each of the cells. And in general, the electronegativity increases from left to right on the periodic table and from bottom to top. So the more electronegative an element is, the more strongly it will attract electrons. And in each of the polar bonds given, we can compare the strength of attraction by finding the difference in electronegativity between the two elements. And the most polar bond will be the one in which the difference in electronegativity is the greatest. So let's have a look at each of our options. The first one we have is carbon and fluorine. So let's go ahead and find those on the periodic table. You can see carbon here, number 6, has an electronegativity of 2.5, and fluorine has an electronegativity of 4.0. Fluorine is actually the most electronegative element. That is something worth remembering. So if we find the difference between those two numbers, for option A, we have 4.0 minus 2.5, and that gives us a difference of 1.5. Our next option is sulfur and bromine. So if we find those on the periodic table, sulfur over here, number 16, has an electronegativity of 2.5, and bromine has an electronegativity of 2.8. So once again, we can find the difference between those two numbers for option B. 2.8 minus 2.5 is equal to 0.3. So that is the difference for option B. Our third option is oxygen and hydrogen. So we can find those on the periodic table. Oxygen here, number 8, has an electronegativity of 3.5, and hydrogen has an electronegativity of 2.1. So finding the difference between those two, for option C, we have 3.5 minus 2.1, and that gives us a difference of 1.4. And the final option that we have is chlorine. So let's just go have a look at what the electronegativity of chlorine is. It is over here, and it is 3. So we find that if we subtract 3 from 3, we will get 0, which is exactly what we expect for a diatomic molecule, because both of the atoms attract the electron to the same extent. So here we've now determined the difference in electronegativity between all of these different atoms in our various polar bonds, and we can say that the one with the greatest difference in electronegativity is option A with 1.5, and that means that the most polar bond is A, carbon and fluorine. Before I go, I'd like to say a very special thank you to our epic sponsor for making this video possible. Read all about them in the description below. Be sure to visit our website for more of these epic tutorial videos. If you can't find the answer to your question, you can send us the question and we'll respond with a personalized video just for you. Until next time, stay epic.